All right, I understand you have a homework due and you guys are busy working on the homework, but we have to get started on this inventory model chapter. I'll try to go a little slow. So, what is inventory models really? It is concerned with two basic questions, right? Suppose you are in the business of selling beer, right? So you sell beer throughout the year, right? What you don't do is, well, you only hold one case of beer and somebody comes, he buys it and you go to the store again and buy another beer or place another order for another case of beer, sell that and wait for another. You don't do that. Neither do you buy, say, if you know that you're going to sell 10,000 cases of beer, you just don't buy all 10,000 cases of beer, put it in the inventory and keep selling throughout the year. I mean, the answer really lies somewhere in between. So this chapter is about two questions. How much should you order? Right? How much should you order at each time? Right? So that basically also means how many times do you have to order, because your demand is constant. So suppose if you know you're going to sell 10,000 cases of beer, these two questions are equivalent. How much should you order at each time, or how many times do you have to order each year? Or the next question is, when should you order? Should you wait till everything that's in your storage is finished, or when should you order? So there's two important questions. How much should you order and when should you order? The goal is you want to minimize the total cost of ordering. Right? You want to minimize the total cost of ordering. Now, what are these total costs? And let's work with the first model, and I'll develop the first model very, very slowly, and I hope you'll understand and appreciate this model. The first model is what we call EOQ models. Okay. So in EOQ model, two new words you learn. The first one, what we'll call holding cost. Okay, sometimes called inventory cost, but either way, holding cost. The second is ordering cost. So what are these things? Suppose again, let's go back to the same model of you're in the business of selling beer, right? Again, the two extreme examples. If you bought all the beer you're going to sell throughout the year, what is the biggest cost going to be? Buy it at one time, and then you're going to have to hold it. You have to build a storage facility, right? You have to build a storage facility to hold all the beers, right? You have to insure all these beers, right? You have to, pay for the breakage. I mean, the more you hold, the more you're going to break it. And all the overhead associated with the guy who puts the beer, brings the beer from the storage, and all these things. That is holding cost. Really, the cost of holding the inventory is holding cost. Ordering cost, the best way to think of this is, so that's holding. Ordering cost is cost of ordering it, right? I mean, it will cost you, the labor, the person who has to order it. Every time you're done with it, you have to order it. The bank cost, I mean, you have to transfer the money and all these things. Transportation, you order it really means, somebody has to deliver it every time. Making vouchers and all these things. The cost associated with ordering it, right? Not the money you pay. I mean, the money you'd have to pay no matter what. I mean, if you buy it all once, you have to pay the money. If you buy it one at a time, you have to pay the money. That's not what we're talking about. The physical act of ordering, the cost associated with that is the ordering cost, right? The cost of holding it is the holding cost. So you see the balance. If you order just once, just the few times, and hold it all, then you have a less ordering cost, right? If you do it, just order once, what will happen? If you order just once for the whole year, then what will happen is your ordering cost will be less. Ordering cost is less, right? Whereas your holding cost will be high. because you have to hold the bigger amount. You need a bigger storage facility. You need more guys to maintain it. You'll have a bigger electricity fee. You'll have more breakage. You need more insurance and so forth. Now, on the other hand, suppose you don't hold anything. You just hold the minimum amount, the amount you're going to sell today. So every day you go buy it from your wholesaler, sell it. Again tomorrow go buy it, sell it, and then again go buy it, sell it that day, buy it. So what happens in that case? Well, your ordering cost is too much. Well, ordering cost here could be just going to the wholesaler and picking it up and writing the check and whatever that is. Your ordering cost is going to be high. Whereas your holding cost would be less. So you see this tug of war going on. So you want to find, so obviously not ordering too much or ordering just one item, the extreme of it is just ordering one item and then every time you sell that you go and buy it from your wholesaler. I mean, that's the extreme of it. Ordering one item on one side or ordering everything you need for the whole year on the other side, it has this tug of war going on. Ordering one item at a time will have a huge ordering cost but low holding cost. Ordering all items at the same time will have a low ordering cost but high holding cost. What you want to do is you want to minimize this total cost. How do we go about doing it? Right? That's the idea. Let's think of this business. This business sells 2,000 cases of beers on week 1, 2025 on week 2, and so forth. So this EOQ models generally is applicable when the demand is constant. That's a very important idea behind important requirement for EOQ models. The easiest models we're looking at. Now, if you look at this, is this really constant? Is this constant? Well, it really doesn't look like constant. I mean, 2000 and 2025 are not the same. But this is where I want to make a point. Well, you're never going to have a real life scenario when the demand is exactly 2000, 2000, 2000 every week. This is as close to constant you'll get. Right? That is why we spend so much time learning introduction. Here, you can confirm it by a very low standard deviation, which means it's pretty close to being constant. So this is an important thing you want to learn. In real lives are not models. Models are usually much more simplified version of what happens in real life.